In April 1986, Commander Operational Test and Evaluation Force, COMOPTEV-4, developed a requirement to provide the Navy with a platform to test and evaluate ship self-defense weapons. The first platform selected was the Decatur, DDG-31. Rescued from the scrapyard and modified with diesel engines, it served its country an additional 10 years as the original self-defense test ship, Sdts. In March 2006, a much more capable platform, the Paul F. Foster DD-964, replaced the aging Decatur. Sdts is home ported at the Naval Surface Warfare Center, Port Hueneme Division in Port Hueneme, California. The Port Hueneme Division is the designated agent for the Program Executive Office Integrated Warfare Systems to act as the on-site manager for Sdts. Sdts provides the Navy with an at-sea, remote-controlled, live-fire, self-defense weapons test and evaluation platform to conduct advanced weapons and evaluation without the risk to personnel. The use of the Sdts in an unmanned, remote control mode of operation also allows the use of tactical missiles as targets. This mode of operation overcomes inadequacies in existing surrogate targets and safety stringencies encountered when self-defense systems are tested on manned ships. Remote weapons and ship control is conducted from Surface Warfare Engineering Facility, SWEF, located at NSWC, PhD. The Sdts is 563 feet long with a beam of 55 feet. It displaces approximately 9,250 tons and has an approximate navigational draft of 32 feet. Propulsion is provided by 4 LM2500 gas turbine main engines with a maximum speed of greater than 30 knots and a normal operational speed of approximately 14 knots. 4 Allison 501K 2,000 kilowatt gas turbine generator sets provide ship electrical power. The Sdts currently supports several weapons, sensors, and support systems, including the AN SLQ-32 Alpha Victor III Electronic Warfare System, Close-In Weapon System, CWIS, Block 1B, Rolling Airframe Missile, RAM System, Mark 57 Mod 12 NATO Sea Sparrow Surface Missile System with Evolved Sea Sparrow Missile, ESSM, the AN WSN-7 Inertial Navigation System, the Ship Self-Defense System, SSDS, the AN SPS-49 Alpha Victor I Long Range Air Search Radar, the AN SPQ-9 Bravo Radar, Mark 41 Vertical Launching System, VLS, and the Test Ship Remote Control System, TSRCS. Other systems may be temporarily installed aboard Sdts as required to support target tracking or live-fire operations. With the ship pierside, Sdts is a waterborne laboratory available for use without the import scheduling problems associated with a commissioned vessel. The combat system or sensor under test can be exercised prior to at-sea operations by undergoing aircraft tracking while the ship is pierside. Aircraft flying on the Point Mugu test range can fly basic scenarios to within approximately 5 miles of the ship's pierside location and can provide essential system operational information, thereby increasing the confidence in system operation prior to the ship leaving port. Testing at anchor can be used when the user requires an at-sea environment yet wants to reduce fuel and/or manning costs. Underway operations can be conducted in either a fully manned mode or unmanned remote-controlled mode, depending on user requirements. Manned testing at sea can include both non-firing and firing scenarios utilizing air and/or surface targets. Aircraft, boats, or radio-controlled aerial targets can be maneuvered to meet user requirements. All unmanned, remote-controlled operations are conducted on the Point Mugu range in the vicinity of San Nicolas Island. In order to conduct these unmanned operations, the Sdts first must transit to the appropriate range operating area. In a typical at-sea operation, food, supplies, and ammunition are loaded the day prior to departure. If the mission is conducted on the sea range, the Sdts usually departs before dawn to maximize time on the range. All personnel and the harbor pilot come aboard, the ship is cast off, and Sdts maneuvers out of the harbor and out to sea. While in transit, Sdts may be required to conduct off-range tracking exercises and CWIS pre-action calibration pack fires. During transit, the weapons being fired, ESSM and/or RAM, will also be uploaded into their respective launchers and tested. Once on station, the test ship remote control system, weapons and sensor systems, and missile telemetry will be operationally checked and tested. Sdts will typically anchor overnight at Dutch Harbor, San Nicolas Island, to await rendezvous with crew boats and the target barge tow tug. Conducting Sdts operations remotely in an unmanned state requires a criticality of timing over a several-hour period. There is a significant dependence on sea state, weather, and available daylight hours, which can dramatically influence the number of hours needed to execute an operation. In the early morning hours, a programmed evacuation of most of the ship's crew and non-essential test project personnel to crew boats takes place, and the Sdts gets underway for the designated operating area. During transit to the op area, remaining personnel conduct final system and remote control checks, verify systems operability, conduct telemetry checks, and turn over remote control of Sdts to SWEF. After a shift to full remote control, remaining personnel are evacuated from the ship by helicopter to San Nicolas Island, where they will wait until the operation is complete.
Stand by to pick up the countdown on my mark.
Range control, copy. Green range for target launch. System armed. Batteries released. Weapons free.
T-minus 5, 4, 3, 2, 1, 0. Target launch. SWEP, you have green range for missile launch.
Range control, copy green range. Stand by for missile launch. Range control, we have hostile track number 87532 on bearing 087 degrees at 22 nautical miles relative.
SWEF, copy 087 degrees at 22 nautical. That is your target. You have green range for missile launch.
Range control, missile away. Missile away. 2 salvos, birds are free. Range control, Mark India, we have missile intercept.
After the exercise is complete, an explosive ordnance disposal (EOD) team flies to the ship, approaching through the safety zone and fast ropes down to the forecastle. EOD manually safes all weapon systems and checks for damage to the ship to ensure crew and test team personnel can safely reman the ship. Once the all clear is radioed to range control by the EOD team, Sdts begins its transit back to San Nicolas Island. The crew and test team personnel are returned to the ship and take local control of all systems. Paul F. Foster continues to successfully carry on the mission begun by its predecessor. Today's Sdts can grow to meet new user project objectives and mission requirements. In addition to having the capability to test and evaluate today's ship self-defense systems, it also has the versatility to adapt to a broad range of future Department of Defense test and evaluation requirements. Sdts, to meet tomorrow's threats today.